Question 27. The reaction between bromide ions and bromide 5 ions is represented by the following equation. So out of the 4 statements, you are to choose which statements are false. All right. So now based on the first 2 statements, when you see the terms reduce, reduction, this is a question that is on redox, right? So how do you tackle redox question? You will need to calculate the oxidation state of the elements in the equation. So let's start with the oxidation state of bromine first in both reactants and products. So we deal with bromide ion with a formula of Br minus. So the charge of the ion is 1 minus, right? So the oxidation state follows the charge of the ion of this monatomic ion, so it is minus 1. All right, the oxidation state of bromine in Br minus is minus 1. So let's deal with the elemental bromine Br2. Okay, Br2 is a neutral uncharged molecule and the oxidation state of free elements, all right, is 0. So its oxidation state is 0. Okay, so now we take a look at the bromide 5 ions with the formula given as BrO3 with a charge of 1 minus, BrO3 minus. So the oxidation state of oxygen in most compound is minus 2. We have 3 oxygen atoms in the formula, so multiply by 3, the total negative charges is minus 6. Okay, let the oxidation state of bromine be X in this ion, right? So I have 1 bromine atom in the formula BrO3 minus, so 1 times X is just X, X minus 6, you equate it to the charge of the ion, which is minus 1. Okay, so solve for X, X is equals to minus 1 plus 6, you get plus 5. So the oxidation state of bromine in bromide 5 ions is plus 5. It is also indicated in the naming, bromide 5 ions. So the oxidation state is plus 5. Okay, so let's also calculate or determine the oxidation state of the remaining 2 elements, oxygen and hydrogen. So now, for oxygen, we know that in compounds, its oxidation state is minus 2. And for hydrogen, its oxidation state in H plus an ion, it will follow the charge of the ion plus 1. And oxidation state of hydrogen in most compounds is plus 1. So I hope you all can see that the oxidation state of hydrogen, it remains at plus 1 and the oxidation state of oxygen remains at minus 2. There is no change. So what can you conclude about hydrogen and oxygen is that they are neither oxidized nor reduced in this reaction. Okay, H plus is neither oxidized nor reduced. The oxygen in bromide ion is also neither oxidized nor reduced as well. Okay, but let's determine the type of reaction that bromide and bromide ions undergo. Okay, so the first one, we deal with bromide ion first. The oxidation state of bromine, it changes, but you shouldn't use the word change. Be specific. How does it change? Decrease or increase? So minus 1 to 0 means that the oxidation state increase, right? From minus 1 to 0, it gets more positive. So as oxidation state increase, this means that Br minus is oxidized, and hence it is a reducing agent. The opposite. If itself is oxidized, it is a reducing agent. So we deal with the other ion, bromide ion. The oxidation state of bromine from plus 5 to 0, how did it change? Decrease, right? Plus 5 drop to 0 means that the oxidation state decrease. So this tells us that bromide ion is reduced, and if itself undergoes reduction, it is an oxidizing agent. So with that being mentioned, let's start to classify the statements as true, correct, or false, incorrect statements. Okay, so the first statement, hydrogen ions, they are reduced to water. The oxidation state remains at plus 1, right? There's no change in oxidation state, no change in OS of hydrogen. Therefore, H plus is neither oxidized nor reduced. Okay, so are they reduced? No, they are not reduced. Hence, this statement is false. Okay, next, statement 2. The bromide 5 ions has undergone reduction. Alright, so let's take a look at the data given here. We have already established that bromide ion is reduced, right? So indeed, it has undergone reduction. Hence, this statement is actually true. Okay, so statement 2 is actually a true statement. Alright, so this means that since the question is asking for statements that are false, we can eliminate option D containing statement 2. We move on to the next statement, statement 3. The bromide ion is the oxidizing agent. We have already established that it is a reducing agent. So this is a false statement. Alright, bromide ion Br minus is a reducing agent. So this means that it cannot be one only, right? So A is false and 3 is a false statement. So the answer for question 27 would be option C. But let's take a look at why statement 4 is incorrect. The oxidation number and oxidation state, they are used interchangeably. Of bromine in bromide 5 ion is plus 5. This is true, right? Because we've already calculated it as such, plus 5 here. True. So 2 and 4, they are true statements. Hence, the best answer for question 27 is option C.